Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Asad Abbas. This lecture comprises of three parts. In part 1 and part 2, we will discuss quality assurance activities and life cycle phases. Then in part 3, we will discuss factors affecting intensity of quality assurance activities in software projects. Okay. First of all, it is important to understand why we need to discuss these models in conjunction with the quality assurance activities. It is because the life cycle models they actually provide a coordinated set of concepts and methodologies that are required to implement the software or to develop the software systems. As such, they include definitions of the main activities that are needed for development. Similarly, they define the appropriate sequence of performing those activities and, of course, defining the milestones. So, software quality assurance activities must take place in conjunction with the completing of the development activities or by examining at the work products that are produced from these activities. Therefore, it is needed to understand the models before we can actually produce the plans that are integrated into these models. So we will discuss the following models from the perspective of examining their quality assurance checkpoints and quality assurance activities. The first one is the waterfall model, then the prototyping model, incremental model, spiral model, and agile development model. The waterfall model. This is also called classic life cycle model, and so sometimes it is also called as SDLC, software development life cycle model. It is one of the most popular and popular models and is still in use today. Actually, like for the projects that have very clear and like well-defined requirements, those projects usually prefer following the activities of this model, or they prefer to use this model. Uh, in fact, this captures the major building blocks in development. So, as you can see here in this illustration, it has a linear sequence. That is, here we have the first activity is requirements definition and specification. So here the user's requirements are defined, and then those requirements are of course specified, means they are in fact transformed into well-defined requirements, of course by applying all the requirements engineering activities. Then the next activity is design, where the systems like outputs, inputs, processing procedures, for example, data structures, databases, and software structures, they are defined. Then is the coding activity. In this stage, the designs prepared in the previous stage, that is design stage, they are in fact transformed into the executable code, whereas the next activity is testing. So testing aims at identifying the defects in the system, and the next activity is that the software is released, and of course it is put into operations, and if it needs some maintenance services or support services are provided. So, in fact, this model is highly structured and plan driven. The product here is delivered for evaluation and deployment at the end of development and testing. And as I mentioned before that it is mainly this model is used for major projects of length. Uh, although it is very popular, but still this model faces lots of criticism. For example, if a design issue appears during the testing stage, we may have to step back to the previous stages. Similarly, because this is because usually the testing in this model it is performed very later at a later stage. So, it is too late that we are able to take some decisions if some defects or some errors may originate at the later stages. Similarly, this model has been criticized for its limited interaction with the user during the development activities. However, later on, improvements in this model were suggested, and feedback loops were introduced. Despite of criticism on this model, it serves as a framework for many other models. Okay, here we will discuss the quality assurance activities in the waterfall-based projects at different stages. In this figure, you can see several quality gates that represent the quality assurance techniques at different points during the development phase. For example, various defect prevention activities such as reviews and inspections. They are typically performed in the earlier phases of the software development before the actual faults have been injected into the software system. Uh, the reason to perform these activities in the earlier stages of the projects is that the error sources are typically associated with activities in these early phases. For example, sometimes conceptual mistakes uh, are made by designers or programmers. Similarly, unfamiliarity with the product domain uh, or inexperience with the specific development tools or methodologies, they might be some reasons for errors. Therefore, to remove the error sources, the software quality assurance techniques are applied in the start. So here you can see that as a first quality gate, we are applying a quality check after requirement specification, that is in between requirements and design. Similarly, from design to coding, we are again applying a quality check. So the first quality check might be a review activity, whereas the second might be some some other for example design inspection or any other activity. So here we can see that in the start our emphasis is on defect prevention. Similarly, other fault detection and removal activities such as testing are typically performed in the later phases of the software development. For example, here you can see that like testing is in fact being performed just before release. It means that majority of or almost all of your code is complete or the product is developed. So we are in fact here going to identify the defects in the system. So again, this is another quality gate that is aimed at identifying the defects. So why we need to have another quality gate here? Because there is a possibility that there might be some errors that have been unidentified during the initial stages of the for example, design reviews or requirements reviews. So they may have propagated in the next stages, or there might be some other errors that might have been committed by programmers while they were like writing the code for the system. So therefore we are actually applying the testing activity, and here our focus is on removal of defects. And finally, the failure prevention and containment activities such as fault tolerance and safety assurance are typically performed when the system is in operations. For example, like if the system gets failed during its operation, then we need to recover the system from, for example, from the point or from the state where it got failed. However, planning and design implementation of fault tolerance techniques, that needs to be carried out and reviewed at different points throughout the software development process. So, in this video, we discussed quality assurance activities in the context of life cycle models. So for now, I will stop my discussion here, and in the next video, I will discuss the remaining four life cycle models and the quality assurance methods or techniques that are applied in those models. Thank you. The materials in this video are taken from the books by Jeff Tian and Daniel Gallen. The first book is Software Quality Engineering, Testing, Quality Assurance, and Quantifiable Improvement, whereas the second book is Software Quality Assurance from Theory to Implementation. Thank you.